Okay, good morning. What we're going to do today is we're going to work on radicals again. We just had a test simplifying radicals, and now, okay, so we're going to work on radicals, and what we're really going to do, and we've done this before, but we're going to look at it slightly a different notation. So if I give you f of x is equal to the square root of, that's a x, okay? So if I then plug in f of 4, what about f at 16? What about f, whoops, at 25? What about f at 64? What happens? So our big deal is, what does this notation mean? Just a review, x became 4. X became 4. X became 25. X became 16. X became 64. So when we're doing this, we're just going to rewrite the problem. So this becomes, f is another way of saying just a square root of x now became 4. X now became 16. X now became 25. Oops. So when we write in this function notation, it just really, x is almost like, it's almost like a space holder. And we can later plug in different values. That's going to be 64 because x is the value we're plugging in. For a lot of this stuff, it's pretty easy now. The square root of 4 we talked about before, the square root of 64, the square root of 25, the square root of 16. It's just 2, 5, 4, and 8. So let's look at another problem that looks slightly different. What if I told you a little different letter, G? F is done by square root of x. G is used by the square root of x. Let's do x minus 5. Okay. Now, if I give you the number, instead of plugging x, I'm going to have you plug in the number 21. What if I give you G is the number 41? So what happens is x became 21, but the 5 is still there. X became 41 here, and we still have a minus 5. So when we're looking at these problems, I might not know what the square root of 21 is, but once I plug it in, I have to first minus 5. The square root of 25 minus 5, 25 minus 5, no, 21 minus 5 is 16. Hey, I know what the square root of 16 is. That's going to be 4. The next problem, the square root of 41 minus 5. I don't know what the square root of 41 and 5 is, and I have to do them together first. You have to do them together first. 41 minus 5 is 36. So square root of 36. Hey, I know what the square root of 36 is. 6. So our first thing is just talk about what do we do with functions and then plug in the values. Now your IXL, the IXL has been posted. It's FF1 and FF4. So we finished all of EE, okay, about radicals. Now today we're gonna plug in radicals and then solve for X going backwards. So, and we practiced that in class. We're just gonna go ahead and practice these problems. So if you look what we have here, this looks kind of confusing in this function notation. So this is the setup here. And what we're going to do is we're going to, let me see if I can write on this. Good. So we're going to say, hey, well, x is now 16. So all your x values we're going to plug 16 in. So showing work, I'm saying f of 16 is really 1 plus, instead of writing x, I'm going to only write the number 16. We talked just a moment about it. Square root of 16 is simply 4, and 4 plus 1 is 5. So do the problems actually get that much harder when it comes to plugging in for these functions? Answer is no. So let's try another one. Let's go ahead and hit done here. And we're going to go ahead and we said the answer was 5. Great job. Yeah. The next question is a very similar process. I'm going to plug in 9 now. X is now 9. Well, this becomes 9. So to show our work, f of 9 is 4 plus 12. Instead of writing x, well, x is now 9. So we write 9. Do we know what the square root of 9 is? Okay, that's going to be 3. So we're going to write a parentheses 3 to show all the work. So why do I need the parentheses? Because if I write it as no parentheses, it looks like 123 rather than 12 times 3. So we write the parentheses just so in case I have to go back to look at it. We know there's a multiply there. We're multiplying 12 by the square root of 9, which turns out to be 3. 12 times 3 is 36. Add them together. 36 plus 4. 36 plus 4 is 40. So the first IXL is just really just practice and just going back to making sure I can know my square roots and I know how to evaluate them. Okay. Let's go ahead and look at some slightly harder versions again as this ramps up in IXL. So this problem here, kind of similar as we started our problems. So we're going to go ahead and say, hey, use the following function rule to find f at 1. So that means all the x values have now become 1. So write it out. F of 1 is equal to negative 6 square root of 120 plus, and we said x became 1. 1. So we're going to rewrite it, negative 6 square root of 120 plus 1. Well, what is 120 plus 1? 120 plus 1 is 121. And know what? I know the square root of 121 now. The square root of 121 is 11. I'll write that with the parentheses, just to make sure you guys can see that there's a spacing there. Through multiplication. That's how we're going to combine these numbers. And the answer is negative 66. And this is just a practice function notation, as we've done before. Okay, we said the answer is going to be negative 66. Awesome. Okay. Does this really get that much more difficult when it comes to practice? No. And then we're into the 90 zone. Oops. Okay, our next IXL problems that we're going to take a look at are going to be solving radical equations. So we're going to go spend a moment to talk about how do we solve radical equations. So let's talk about how we solve any answer like we normally did before, on any function. If I write y, no, let's go a different way. Let's say 3x plus 2 is equal to 8. And I ask you to solve. And when I say solve, I really mean solve for the unknown variable. Right? Solve for the unknown variable. And many of you guys probably could guess what x is. X is probably going to be 2. Right? Thank you. So we can see it's 2. I pretty much use this example almost like once a week. And we said to solve for x, we have to get rid of all our little friends here. It means we're going to get rid of the 2, get rid of the 3. We worked on which one do I get rid of first. We said get rid of what's farthest. And what's farthest from me here is going to be the 2. So the opposite of plus 2 is minus 2. So we're left with 3x equals to 8 minus 2 is 6. Okay. Very simple process. Then we will go ahead and say, hey, what's the opposite operation of multiply by 3? It's divide by 3. And we're left with x is equal to 6 divided by 3 is 2. And if you go ahead and plug that in, 2 times 3 is 6. And 6 plus 2 is the 8 that we got. Amazing. Yes, hold down the applause. So this was back from last semester. And since then, we've been learning different tools to solve for new types of problems. And we were looking at square roots now. So let's go ahead and talk about the square root, a radical. For us, square roots. And if I give you the square root of x is equal to 4. Now, a lot of people will naturally say, hey, the square root and 4, that's going to be 2. It's just because we're just throwing out answers. Some of you guys might have figured out what this is going to be, in other words, but let's go ahead and go through the process. Now, looking back at our last question, every operation for us had an inverse operation, an undo operation. Well, our undo operation for addition is subtraction. Our undo operation for multiplication is division, right? And our undo operation for a square root is going to be a square. So what we're going to do on our next step here, I'm going to rewrite the problem so you guys can see it. And I'm going to do the opposite operation, the inverse operation of a square root. Now remember, square roots look for pairs. So the opposite of that is to not look for a pair, but to give it a pair. What I mean by that, I'm going to make it into a pair. Make it into a pair on both sides. So as we're making this into a pair, a square and a square root, we said that's going to be opposite operations. So this actually automatically goes away. And we're left with what's inside. It's almost like peeling an onion. We peeled out the outer layers. Is equal to, and 4 squared is 16. Let's see if that worked. If I took the square root of x, which is now going to be 16, is that equal to 4? Square root of 16 is 4. That's our answer. So as these problems get a little more tough, a little more things going on, so let's do another one. Here's my next example. Let's call example 1 and example 2. The square root of x plus 3 is equal to, let's do something. Let's do it as 7. So as we mentioned before, as we solve for x, we want to get rid of what's closest or what's farthest away. And my story in class was, if you have people in your room and you want them out, you don't get rid of the people closest to you. Get rid of people closest to the door, farthest away from you. So in this case, it's either the square root or the 3. Who gets to get kicked out first? The farthest from me is a 3. So what's the opposite operation of plus 3? Opposite operation of plus 3 is a minus 3. Well, after I do this step, square root of x pretty much becomes back to my last answer. As we clean up our problem, it should become easier to deal with because there's less things to worry about. Just like your homework. If you guys have like 20 problems to do, right? As you whittle them down, as you work one by one, you have less problems. Your paper looks a little cleaner. Your calendar looks a little nicer. Your house looks a little neater. So from here, we ask ourselves, how do I get rid of a square root? The inverse operation, the opposite operation of a square root is a square. You know what? I'll rewrite this so you guys can see a little nicer. Rewrite the problem. The square root of x equals to 4. And then we're going to square both sides. That's the opposite operation. And a square and a square root nicely get rid of each other. And we're left with x, because the square root was peeled away. And 4 times 4 is 16. Now, this is kind of a wild guess, right? But let's go ahead and plug it back in to verify. Let's verify your answer. So we said square root of x plus 3 is equal to what? And x is going to be, in this case, we said it's going to be 16. The square root of 16 is 4, and 4 plus 3 is 7, just like what we wanted. Let's take a look at the IXL to see. Let's do one more actually. What if numbers were inside the problem? And so inside the square root. So if I write square root of x plus 4 is equal to, let's do something like 3. So in this problem here, take a look at the x and take a look at the 4 and the 3. We have to get rid of the 4, so x can be alone, as well as the square root. But which one do we get rid of first? The 4 on the inside or the square root on the outside? Which one would you consider to be farther away? It's almost like, is the person next to you farther away, or like the roof on top of you farther away? I'll say the roof on top. So for this problem, how do we get rid of a square root? How do we get rid of a square root? What was our inverse operation? What was our opposite operation? And we mentioned before, that is a square. And in algebra, if I do something to one side of the equal sign, I have to do the exact same thing to the other. That's fairness. A square and a square root, we mentioned before, get rid of each other, gone. So all we keep is what's inside, x plus 4. And 3 squared is 9. Almost done here. We're going to get rid of the 4. Opposite of plus 4 is a minus 4. Opposite operations. X equals to 5. Now, I would never have guessed that. I don't even know if that's the right answer. I didn't skip any steps. I didn't make any shortcuts. I didn't cheat my way through this by making something up. So I followed my rules, and this should be the right answer. Let's go ahead and try it. The square root of x plus 4 equals to what? And we said x is going to be 5. 5 plus 4 is 9, and the square root of 9 is 3, like we were hoping for. Okay. So this new skill, not really a new skill, we've actually covered it before, is about how to get rid of a radical. Okay? And that, in this case, is squaring it. Now, just on the side, just because we have some time here, what if I write, example 4, what if it was a cube root? Now, what is a cube root? A cube root looks for not pairs, but sets of 3. If I take my box method, 3 goes into 27, 3 goes into 9, oops, remainder 3. As you guys can see, I have 1, 2, 3, 3s. And cube roots are looking for sets of 3s. Do we have a set of 3? We do. The answer is 3. So if I give you a follow-up question, what is the cube root of x to become 3? Okay, as you can see here, the answer should be 27, right? Answer should be 27. So the opposite operation, let's say this. If a square root is to square something, a cube root is to cube something. A square root is to square, and a cube root is to cube. So in this case, we would just go ahead and not square root, but cube root it. Sorry, not cube root, cube both sides. And a cube and a radical, a cube root, should get rid of each other, leaving me a nice x. And 3 times 3 times 3, 3 cubed is 27, which is our answer that we had. If this was to the fourth root of something, we would do the fourth root, because I need 4 to get rid of them. Fourth root to both sides. If this was 5, we would do 5. Now the tricky part again is to look back here, is when do I do which? For instance, in our example number 2, do I get rid of the square root first or the 3? Ask yourself which one's farthest away, the 3 or the square root, if I was peeling this onion. Example 3, what do I get rid of first? The 4 or the square root? Peeling the onion, it's actually the square root first, and then I can get rid of the 4. I think that's really where you have to make sure you don't make a mistake, that critical thinking part. So let's go ahead and take a look at these types of problems. Level 1. So looking at this problem, to solve for n, I don't have to get rid of this square root. For us to get rid of this square root, I would just have to square both sides. And that's n. See, they just want n pure, filtered clean. Is going to be 13 squared. And 13 squared is 169, because 13 times 13 is 169. Okay. This is going to be 169. Excellent. Yes, yes. This problem is a fraction. It looks kind of scary, and we don't like fractions, but we just follow our basic rules. We're solving for, in this case, w here. Now, how to get rid of a square from the square root? To get rid of it, we have to square both sides, because that's the opposite operation of a square root. When I do that, the square and square root go away. So we're left with letter w is 1 over 4 squared. Now, when I say this, fractions actually aren't hard when it comes to multiplication. What is another way of writing this? This is 1 over 4 times 1 over 4. So when you're multiplying fractions, it's top times top, or just 1 times 1. Or in this case, just say 1 squared is 1. Bottom 4 times 4, or 4 squared is 16. So it's actually pretty quick. And this is the case when I'm squaring any fraction. When you square any fraction, you square the top and you square the bottom. You square them separately. So this to become one of his. If I give you another example, if I say, what's the square of 1 over 5? You square the top, 1 times 1. 1 times 1 is 1. And 5 times 5 is 25. Yeah. Let's go ahead and plug in our answer. We said it was 1 over 16. Okay. So these problems can be done pretty quickly. Remember, your goal is to get up to 90. Now, as we mentioned before, this is our example 2 problem. Do we get rid of, take a look here, do I get rid of the square root first or the 2 first? Which one is on the outside? So which one's farthest away? Like an onion, peeling an onion. So if you said the square, good job. So I'm going to get rid of the square root by squaring it to both sides. B plus 2 is equal to 4 squared. Hey, 4 squared is pretty easy. That's a 16. To get rid of the 2, opposite of plus 2 is a minus 2 to both sides. B is equal to 14. I wouldn't have guessed that. 14 plus 2 is 16, and the square root of 16 is 4. Yeah, we're solving for that variable, that unknown variable. Oops, what'd I do? Whoops, I wrote 16, I'm in 14. Oops. Okay. This problem here, like we mentioned before, do I get rid of what first? The square root, or in this case, the 1 here? Square root or 1? Which one's farthest away from the y? So I would say farthest away is the 1. Opposite of minus 1 is plus 1 to both sides. 3 is equal to the square root of y. Now, using our rules, how to get rid of a square root, we use a square to both sides. 9 is equal to y, because the square root and the square cancel each other out. And we can try this, double check. 9, so square root of 9 minus 1 is really 3 minus 1, which is the 2 we wanted. I'm going to pause for a moment. So on this problem here, you see there's actually like 3 things going on. In this case, 4 things going on. So let's go ahead and take our time, making a decision, what should we get rid of first, making a game plan. So I'm solving for b, and b is kind of trapped in the square root. So let's talk about what's farthest away. So I'm going to claim that 7 is my farthest away, so we'll get rid of this first. Then in order to get at the b, I can't touch the 2 or 11. I need to get rid of the square root. So then we'll get rid of the square root next. After that, we have a -2 and 11. 11's farthest away, so we'll get rid of the 11. And then we'll get rid of the 2 at the end. Okay, so we have a game plan here. Let's go ahead and get started. We'll rewrite the problem. -2 is equal to the square root of -2b plus 11 minus 7. Opposite of, we said we're going to get rid of the 7 first. Opposite of minus 7 is plus 7 to both sides. 7 minus 2 is 5. Now how to get rid of the next thing, the square root. The opposite operation of a square root is a square. This becomes 25 equals to -2b plus 11. Because the square root and the square, I mentioned this before, square and square cancel each other out. So we don't write it anymore. It's gone. Our next step, we said -2 or 11. We mentioned that we were going to get rid of the 11 first because it's farthest away. 25 minus 11 is 14. Oops. Excuse me. And then we're going to divide both sides by -2. B is equal to -7. So that's the most unlikely answer. I mean, well, all answers are possibility. So let's actually just try it. Let's plug it in and see if this kind of worked out. So -2, does that equal to the square root of -2? What is b? We said b was going to be -7 plus 11 minus 7. So let's go ahead and work out this problem. -2 times -7 is a positive 14. Positive 14 plus 11 is positive 10 plus 10 is 20. 5 plus 1 is 5, so 25. The square root of 25 is 5. And 5 minus 2, no, 5 minus 7 is -2, which is what we wanted. Okay. Hopefully this basic run through of all our ways in Algebra 1 for us to solve for x inside one radical wasn't too challenging. And we're going to actually work on 2 radicals next time.